Hey, can you hear me now?
Yes, we are.
Oh, okay, perfect. I was mute.
Okay.
Okay. Hello, everyone. Hello, everybody. If you haven't joined to my Telegram group, that's the moment because you're gonna need to join for send me all type of question and solutions. So please join now if you haven't joined yet. And of course, at right you can find the GitHub repository where you are going to find all the material. So please go to the GitHub repository. And now we are going to start with the advanced fuzzing workshop. That's the second edition. I did a first edition in EcoParty 2 months ago, and it was an incredible experience. So I have chosen to repeat the experience here in Hackfest. So who am I? I'm Antonio Morales. I work as a security researcher at GitHub, and that's my Twitter. Please follow me. You are going to be able to see some interesting posts at Twitter, and that's my team. As I have said, I work at GitHub, and to be more concrete, I work in Security Lab, in GitHub Security Lab. So what is it, GitHub Security Lab? Well, GitHub Security Lab is a team inside GitHub, obviously, whose objective is to find vulnerabilities in open source software. So that's are only a few examples of what we usually do. We usually publish some articles, some blog posts, and if you want to get more information about our daily work, go to securitylab.github.com. And that's it. That is a brief motivation, because at the end, this is a fuzzing workshop, and the first motivation of fuzzing obviously is to find bugs in software. In that case, we are going to try to find bugs in 3 challenges, as we are going to see now. And are only a few examples of my work during the last year. These are some of the bugs that I have found in the last year. And the end of the workshop obviously is also to have more knowledge about fuzzing and to understand the difference between a dumb fuzzer, or a person doing dumb fuzzing, and a people doing smart fuzzing. So our main goal is to do a real smart fuzzing. And now, first of all, I'm going to explain the workshop format. This workshop is a CTF style workshop, and the idea is that you are going to learn about fuzzing, about AFL, through a learning by doing method. So you are going to learn while fuzzing 3 challenges. My goal here is to guide you to find the solution and to give you some tips about or during the challenge. What do you need in order to take part in the workshop, in the fuzzing workshop? Well, all you need is AFL++. It's all the software that you need for this workshop. And of course, you are going to need also a running Linux system. So please, if you haven't downloaded it yet, do it now. Go to github.com AFL++, and please download the last AFL release. If you don't have experience about install AFL, please go to building and installing AFL. Okay, and now I'm going to explain the rules because, of course, it's a CTF, so we have some rules. But before, if you haven't already joined to the Telegram group, please join now because you are going to need it for sending me questions and obviously your solutions. So please join to our Telegram group. And now, rule number 1. Challenges are intended to be solved by fuzzing. What does it mean? You can use whatever method you want, but all the challenges are intended to be solved by fuzzing. And if you try with other methods, it's going to be probably quite hard. There may be more than one correct solution. And after each challenge, I will show my solution and I'll give you a little brief explanation about what I did or how I solved. Rule number 2, there will be 3 different challenges. And the goal in each challenge is to find a reproducible bug on each of them. So we are looking for exploitable vulnerabilities. In this case, theoretical bugs, code warnings, or memory leaks are not welcome. So you need to understand that we are looking only for real vulnerabilities. And of course, in order to be the winner of a challenge, you must provide a valid crash or proof of concept. You don't need to send a functional exploit, you only need to send a valid crash. Okay, rule number 3, please don't disclose your solutions. Send me a private message via Telegram or any question that you could have, please send me them via Telegram. Don't disclose your solution because at the end, if you are facing a challenge, you want to get some a good experience from it. And the last one, rule number 4. I will give you some hints and tips before and during the challenge. I am going to release a new hint every 5 or 10 minutes approximately. So don't despair and keep trying. Try hard. And now is the time to present you the awards. There will be 2 winners for each challenge. So there are 3 challenges. So in total, there will be 6 winners. The winner will be the fastest one in solving each challenge or in finding the vulnerability. And what are the prizes? That are the prizes. I'm going to connect my webcam so you can win a t-shirt like this or a hoodie or whatever you want in the GitHub shop. So now it's the time for question. Do you have any question? If anyone has any question, please do it now. Okay, any question?
It's looking fine. I don't see any question in the panel.
Yes, so the thing is, I'm not looking at the panel now. I'm looking only at Telegram. So please join to Telegram if you have any question to do this question. Okay, and now I'm going to start with challenge number 1. Okay, Can you hear me now? Christopher is saying that he can't hear me.
I'm hearing you.
Okay. Okay, perfect. So now we are going to start with challenge number 1. So please go to the GitHub repository and download the file fast1.zip. It's a compressed file, and you are going to need this password in order to be able to uncompress it. So okay, any problem? Have you been able to download the file? I need your feedback. Okay, don't say that the file has worked for him. Okay, perfect. So once you unzip this file, you can build using GCC. Is as easy as you can see here, and you can run in the same way. You only need to provide with an valid input file, and you need also to provide the output path. So that's it. And now we are going to start with the first tip. That's the first tip. So now we are going to have about 5 minutes in order to set up everything, and then I'm going to show you another hint, another tip. So that's the moment of that's the beginning of the challenge. So let's go. Okay, I would like to have some feedback. You can write it down in Telegram. You can tell me whatever you want. So please give me some feedback. Now I'm asking some question in Telegram. As I have said before, if you haven't joined yet, if you haven't already joined, please, it's the time to do it. That's the URL for the Telegram group. So please join now, because I'm solving all the questions in Telegram. Okay, hands up who has been able to unzip the file and who has been able to run AFL. At this moment, all the people should be able to run AFL GCC and to see the AFL interface. Is that okay? Okay, there are some people asking me again about the password. That's the password. Hello 3487 hello. That's the password that you need for unzip the file. Okay, any question? Any feedback? Okay, Predator says that it doesn't show his anything. Yes, you need to download it from from GitHub. Yes, you are gonna find the folder inside the zip file. So please, you can find it inside. Okay, Predator, can you send me please a screenshot? You can send me a screenshot by Telegram, please. Okay. Okay, does everybody been able to run AFL? Okay, okay. So now I'm going to show you my first hint. That's the hint number 1. So please use address sanitizers and undefined behavior sanitizer. To do this, you only need to add these flags. Don't forget to add also the memory known option to your AFL command line. You can see below an example of compiling using address and undefined behavior sanitizer. And below, you can see also an example of AFL running with address sanitizer enabled. Okay, I'm getting some questions about the workshop format. As I have said, this workshop is a CTF style, so you don't need to wait for the next hint or for the next question or for the next step. Your goal is to find the bugs before than any other people. So that's your goal. Okay, I have a question about, I have received a question, sorry. I have got a question about an error that say that the target binary crashed suddenly. If you are receiving this alert, if you are receiving a target binary crash suddenly, please set up the M known option. So you can see the slide. Third line, don't forget to add the memory known option to your AFL command line in order to be able to fuzz using address sanitizer and undefined behavior sanitizer. Okay, while we waiting for the people that are still coming, are still getting into the workshop, I'm going to remind you what is the password. The password is hello3487hello. Okay, there are some people asking me about the that they are still getting the target binary class saddling even with the M known flag. Okay, you need to know that you need to put it down this option at the beginning. What does it mean? You need to put the option just after AFL fast. You cannot put this option at the end, because at the end you are writing the command line, the execution command line. So it's not valid to put it down at the end. Okay, I have another interesting question. Somebody say, is there an argument for multiprocessing? Okay, yes. AFL has multiprocessing support, but for this workshop, I don't recommend it. So you don't need multiprocessing now, and that's my advice. Okay, at this moment, I'm currently I'm answering some questions, so we are going to wait for another 5 minutes. Some people have just joined, so please, if you haven't already joined, go to our Telegram group. That's the URL, fuzzing 21. Yes. Blinils or Blinils, sorry, I'm not able to pronounce your name. Blinis has said that he got an error, a fatal error, because he didn't have OpenSSL in his system. So please, if you don't have OpenSSL in your system, you can install it with this command. Okay, David says, or David asks, where is the AFL GCC binary? Okay, David, you need to install it. You need to download AFL from this URL, and you need to follow the instructions in that URL. Okay, now I'm going to give you another hint. That's the hint number 2. While I ask some other question, that's the information that you need now. Code coverage. Okay, code coverage can be really useful here. So you can enable it adding the next flag. If you haven't installed lcov, please install it. You can install lcov using the next command. And you are going to find also a code coverage script in the folder, in the zip folder. Okay, I'm asking all the question, but if you see that I take a bit late, so it's because I'm asking the question. So please wait a moment. Okay, there are some people asking me or telling that they got an error in gen.html. So if you see a message that says no valid records found in trace file, remember that you need to add the coverage flag to your compile line. So You can see my screen. That's the flag you need to add in order to be able to compile with code coverage. But remember, don't use AFL GCC for getting code coverage support. So I'm going to type it down. That's what you need. GCC Hackfest 1 dots. Right? That's what you need. When you want to get the code coverage, you don't need to use AFL GCC, only GCC. Ah, sorry, my friends. Yes, you need to modify the eco part. Sorry, it's a it's a bug. Okay, it's a typo. Yes, I maintain the eco party path. You need to modify it and put Hackfest 1. Sorry for that, for this typo. As I have said before, the first edition of this workshop was imparted in Ecoparty. So okay, and now I'm going to show you another important hint. That's the hint number 2. You need to think about something known as checksums. If you don't know what checksums are a code or a set of bytes that or whose mission is to preserve the integrity of a file. So for this tag, in order to be able or to be able to fuzz, you need to disable it. So please take a look at that URL. Okay, Aimee is asking about code coverage. Code coverage does not go up from about 35%. And his question is, do I need to fix the source code? Yes, that's it. You need to fix the source code. And you can take my advice or the hint number 2, and you need to think about how you can modify or how you can fix the source code in order to be able to disable these checksums. So that's your goal now, to disable the checksums. Because of course, you're not going to be able to fuzz an input file if you have checksum, because every time that the fuzzer modify a bit, the checksum goes wrong and the application is going to exit. So yes, you need to modify the checksums. Okay, only as a reminder, if you haven't downloaded it yet, go to the GitHub repository and download the zip file. That's the password, hello3487. That's the password for the zip file. Okay, yes, that's it. Erlands has said to me that he has added the coverage flag, and now he can see the coverage inside the HTML. So that's it, Erlands. That's it, how it works. That's the file that you need to see to open if you want to see the coverage. That's the path. HTML coverage index. Only as a reminder, you need to fix the eco party word by the Hackfest one. Okay, Eric or Eri, please write me a private message, and I will be delighted to answer you. So please put me a private message. Sanu, what's the main object of fuzzing? Okay, that is supposed to be an advanced workshop. So, but I don't have any problem explaining it. The main object of fuzzing is to find vulnerabilities in the software. In this case, the main goal of fuzzing is to find vulnerabilities in these three challenges. So that's the thing. The fuzzer provides your software with random mutations of your input, and how it and that's the way it works. Okay, I continue answering some questions. So please give me a second. Okay, yes, Eri, you can see the commands here in the current slide. Here, challenge 1, hint number 2, you can see that all you need is coverage flag. So you need Yes, of course. Before to get the code coverage, you obviously need the AFL task, or you previously need to have done the AFL step. So for everyone, if you haven't haven't already done, do it now. All you need is this AFL GCC. And below, you can see that you're going to need lib SSL dev in order to compile this code. Okay, I'm answering at the same time that I'm speaking, so please be patient because I need to answer to everybody. So okay, now I'm going to do a brief summary of the process. So first of all, what we need to go to the GitHub repository, download the fast1 file, fast1.zip is a compressed file. You are going to need to use this password, hello3487 hello, in order to uncompress the file. And then you can compile using the next command line, AFL, GCC, the input and the output, and that's it. And after that, you will be able to fuzz using AFL fuzz. Then the hint number one is to use address sanitizer and undefined behavior sanitizer. So in order to enable it, use the f sanitize equal to address and undefined to your command line. You can see it below. Below you can see the whole command line. And then don't forget to add the memory known option to your AFL command line. The next hint that I have told you is to employ code coverage. Code coverage can be really useful here for getting an idea of what functions are we hitting. So please enable your code coverage. Only as a reminder, when you enable code coverage, you need to use GCC, only GCC, not AFL GCC. And that's the next hint. Sometimes checksums can be a pain in the ass, that's obviously. So that's the URL that you need to go if you want to get more info about how to avoid checksums. Okay, the question between AFL GCC and GCC. Okay, GCC is just the compiler, is the normal compiler, is the C compiler, and AFL GCC is the instrumented version. So what AFL GCC does is to add some instrumentation inside the code in order to be able to get the coverage, because you need to know that AFL is a code coverage guide faster. So what AFL GCC does is to add some code coverage instructions inside the code. Yes, that's it. I may. Yes, Johan. Thank you. Thank you so much, Johan. That's the URL. Okay. I'm going to give you a new hint. That's the hint number 3. At this moment, anybody has been able to provide me a valid crash, but maybe with this new hint, you can go further. So that's the hint number 3. In this case, you can see 2 obstacles. Well, they are not obstacles. They are CRC and MD5 checksum. So we have 2 obstacles, and our goal now is to avoid these obstacles in the code. Email says that the program doesn't crash. Yes, it will do it. Okay, when after in 10 or 15 minutes, I'm going to show you my my solution. So don't desperate. But of course, there are still some hints that are going to help you. So keep trying, and if you have any question, please ask me whatever question you have. So we are going to do again a brief summary of what we should done. Okay, first of all, we need to go to the GitHub repository, download the zip file fuzz1.zip, and you need to use the hello3487 hello password. Then you will be able to fuzz to compile before using AFL GCC. AFL GCC instrument the source code in order to be able to get the code coverage. And after that, you are going to be able to start fuzzing using AFL fuzz. That's all what you need to start your fuzzing task. Then my first aim is to use address sanitizer and undefined behavior sanitizer. And don't forget to add the memory known option. My second hint is to enable code coverage. Remember that you need to use the code coverage flag when you are using GCC, not AFL GCC, because when we set the coverage flag, we don't want to fuzz. We want to obtain this file, the HTML coverage index file. That's the file that we want to obtain. That's the coverage of the code. So, and yes, of course, there is a typo inside the script. You need to change the echo party word by the Hackfest one. Okay, the next hint is to avoid this obstacle, the CRC and the MD5 hash. So in order to be successful, you need to think about what the code is doing here. On the left, you can see that there is a CRC check. And on the right, you can see another comparison. Of course, there is a main comparison instruction. So maybe that's your solution. That's all what you need in order to bypass the CRC check and the MD5 hash. So all you need is to comment 4 lines in the code in order to bypass the CRC. That's a common procedure when you are fuzzing. Obviously, if you want to fuzz a protocol that has a CRC or any type of hash integrity function, you need to disable it before to start fuzzing it. Okay. And now I'm going to give you another big hint. That's the hint number 5. A dictionary can be useful sometimes. And in this case, a dictionary is going to be really useful. So what is my advice? My advice is to use the dictionary option in AFL. All that you need is the X flag. You can see here in bold. That's all what you need. And of course, you need to create a dictionary. That's your task now. Okay, in this link, you can find how to create a dictionary. So if you don't know how to create a dictionary for AFL, go to this URL and look for the providing a custom dictionary entry. That's the part that you need to look at it. Okay, that is gonna be my last hint for challenge number 1. And the thing is what we need to include in my dictionary. So what you need to include in the dictionary is not difficult to guess. what you need to include in the dictionary is the dictionary array. That's all what you need to include in the dictionary. Okay, 5 minutes left. Repeat, 5 minutes left. If in 5 minutes nobody has been able to find a valid class, I'm going to show you my explanation. I'm going to show you my solution. And okay, there are some people asking about how to copy this dictionary. Okay, this dictionary is in the code, obviously. You need to look into the code for the dictionary array. So you don't need to copy from the slide. The thing is that I have shown to you that that is the information that you need to copy into your dictionary. But of course, this dictionary entry is inside the code, the source code. Okay, 3 minutes left. There are some people asking me about where they can find this array. This array is included in the header file, not in the C file. It's in the header file. So please open the header file and look for it. Okay, 1 minute left. Okay, there are some people asking me about the command line that they need for fuzzing using the dictionary. Okay, 1 minute left, and then I'm going to show you my solution. Okay, I'm going to give you another hint. You need to write the dictionary entries in this format, using this format. So I have written down in the Telegram group. That's the format that you need to use. Whoa, 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 whoa. We have a winner, or maybe we have, yes, it looks like a valid crash. Okay, Tom, can you send me the crash file? I need to verify. I'm going to give an extra 5 minutes because I'm going to verify the Tom crash. So please, Tom, send me the crash. You can find the crashes inside the. Okay, yes, Tom has found like 38 crashes. So please send me whatever you want. And of course, are all the same bug, but AFL are not able to distinguish between uh, these bugs, but it's only a bug. Okay. Now I'm going to check the Tom solution. Perfect. We have an official winner. Tom Richards is the first one in solving the challenge number 1. So 2 minutes left because there is an empty second place for another winner. So we are going to wait another 2 minutes and then I'm going to show you my solution. One minute left, and then I'm going to show you my solution. So if the second place remains left, remains without a winner, there will be 3 prizes for the, or 3 hours for the challenge number 2. Okay, time is over. That's my solution. Time is over. We have a winner at this moment, and that's my solution for challenge number 1. That's the dictionary that you need to create in order to find this vulnerability. And that's the vulnerability that you can find using fuzzing. There is a float pointer exception. There is a division by 0. So the thing is that in order to be able to fuzz, oh, damn, I just got it. Okay, Raf, send me the crash and it is still valid. So Raf, send me your class if you have it. And yes, I'm going to share my screen now. Give me a second. Okay. Okay. Can you see my virtual machine now? Yes. Okay, we have a second winner. Raf is the second winner of, or Rafe, I don't know, is the second winner. So I'm going to update. So the first winner is Tom Richards, and the second place is for Raf. So now I'm going to show you my solution, of course. I'm going to show you how the process is. So first of all, I'm going to show you the code. Okay, can you see my Eclipse ID? Okay, perfect. So why you need to give a dictionary to or to provide a dictionary to the fuzzer? The thing is that in some occasions, like in this case, you're gonna find in the code some tags that are quite difficult to guess by the fuzzer. In this case, for example, you can see here 5 tags. Each tag has 4 bytes. 4 bytes. So it's quite improbable that if the fuzzer found it only using byte mutation, because if you have 4 bytes, you have 2 po 32. So you have 4 gigas of, or 4,000 millions of probabilities with 4 bytes. So it's quite improbable that AFL found it by itself. So in these cases, you are going to need to provide a valid dictionary for bypass these tags. And now I'm going to do the fuzzing process. Okay. First of all, we are going to compile the code. So we have hackfest1.c, and first of all, you need to compile using AFL GCC and the flag fsanitize address and undefined. So first of all, we are going to compile the code. That's it. And now we are going to fuzz providing the dictionary. What dictionary? So the dictionary is that, as I have said before to you, that's the dictionary. This dictionary contains the tags that we have found before in the source code. So that's the dictionary that you need to create, and then you can start fuzzing it. Okay, give me 1 second. I'm going to check that what I have in my AFL in. Okay, so what we need is file 1, and now can start fuzzing. So first of all, AFL start with bit flip operations. What are bit flip operations? Well, you can guess. I'm sure that you can guess. All what AFL does is to flip bits of the file. After that, AFL moves to arithmetic operations. At this moment, are doing 8 bits arithmetic operations. At this moment, 16 bits arithmetic operations. Yes, and I'm going to post now the AFL command line. Give me 1 second because I want that people see the crash. Okay, at this moment is about 1 minute. And now he's going to start with dictionaries. Okay, but before I need to check that I have comment the code, the MD5 code, sorry. Okay. So first of all, we need to comment this code. The main comparison, this is a MD5 hash. So it's the same that with CRC. We need to comment it in order to bypass and the CRC. Okay, we are going to comment it out. Okay. That's the first step that you need to do. And then we are going to compile the code again. Okay, now you need to put AFL GCC. You can see in my screen here, you can see the command line, Johan. All what you need is AFL GCC, then the input file, in that case is hackfest1. Then you need to include the libraries for the linker. Then you need to write it down the output, and then you need to enable the fsanitize. In this case, we are enabling the address sanitizer and define behavior sanitizer. And of course, as I have explained before, you need to comment it out, these 2 lines and the MD5 lines. And then you can go with the compiling. Okay, now you can go with the AFL fuzz. AFL fuzz, memory known. With this option, we are disabling the memory limit because address sanitizer get a lot of memory. So, and then you write the input directory. In that case, we are setting AFL in. So if these are our main path, we need to create an AFL folder and inside an AFL in folder, and that's the example that I provide you. Then you need to specify the dictionary entry. That's the dictionary entry with this content that are the 5 tags. And then you need to specify the run command line. Okay, so we are going to run AFL fuzz again. Okay. It doesn't need so much time. We need about 1 or 2 minutes in order to get the crashes. As soon as AFL reach the dictionary step. As you can see at this moment, AFL are running the bit flips operation. Now the byte flips operation at this moment is with arithmetic operations. Yes, all the slides are going to be upload to the GitHub repository. And yes, you are going to, or you can find all the solutions after the workshop. Yes, that's it. Okay, at this moment, as you can see, AFL are doing the arithmetic operations. So we are going to give it a little bit more time. Okay, we are getting closer. At this moment, AFL are running the interest option that provides the software with well-known numbers, with common tags, and etc. And now the next step is the dictionary step. The dictionary does it. You can see now the unique crosses. So the thing is that AFL is unable to distinguish between different or valid or unique. In this case, AFL is are not able to distinguish between unique bugs. So you can see 39 unique bugs. That's not true, obviously. It's always the same bug. And the bug is here. We are looking, the bug is, where is the division? Now I'm going to show you the buggy code. So that's the ground, or that's the ground function, yes. And here is the bug. Here we have a division, and you can see that the n argument is provided to the function. So this argument, in some circumstances, in some occasion, could be 0. And as you know, a division by 0 is a float pointer exception. Yes, float. You can divide by 0, so that's the bug. So, and now we are going to continue with the challenge number 2. Okay, time for challenge number 2. Can you see my screen? Can you see the slides? Can you see the challenge 2 slides? I need your okay. Okay, yes, okay, perfect. So again, go to the GitHub repository and use this password for uncompressing the file. That's the password, fast9283fast, and the file is fast2zip. So after the previous experience that we have gained with challenge 1, the procedure is going to be easier. We can do the same. we can use GCC in order to compile the code, and all that you need for running the app is to provide it with a valid XML. In this case, we have a text-based file. We have a text-based format. So if you open example.xml, you are going to be able to read the code. So open the example file and you will see something like this. Something like this. Okay, I'm going to show you again the password. The password is fuzz9283fuzz. Please let me know if you have been able to uncompress the file. Yes, thank you, Ray. Okay, we are gonna wait. Okay, Blinis has given his hand up. Okay, we are gonna wait 1 minute and then I'm going to show you the first hint for challenge number 2. Okay, let's go. That's the first hint. Pay attention to the interface, to the AFL interface, I mean, and look at the interface and ask you if there is something wrong, if there is anything wrong in the interface, in the AFL interface. So first of all, you need to run AFL. All you need to do is to change Hackfest1 by Hackfest2, because in this case we are going to fuzz Hackfest2 file, and before you can proceed in the same way. AFL GCC at first and then AFL fuzz is all you need. And that's it, the first hint. Okay, and I just got an interesting question by Tom. The question is, when we got the crash file, we didn't verify that it bypassed the original version of our code. And the answer is that I haven't saw it, but you need to fix the checksum in the crash file in order to be able to exploit the original source code. So before the workshop, I'm going to upload a valid crash file with checksum fixed. The thing is that we only have 2 hours for explaining a little bit complicated topic, so we need to go fast. But in another scenario, in another situation, we will go a little bit slower. Okay. Has anybody does anybody have any type of any question? I mean, have you find something strange in the AFL interface? Yes, that's it. That's the hint number 2 for challenge 2. Okay, after after get running AFL, you're gonna see that the stability is going down. In this screenshot, you can see that stability is about 25%. In an ideal scenario, we should have a value over 90. So, and in general, we need an stability over 90% when we are fuzzing. And what's the reason for this? The reason is that the stability tag told us that there is some problem with the coverage, that the fuzzer are obtaining a random path. So what we need to do is to see what's happening first and to try to reduce the randomness in our application. Remember that AFL is a code coverage guide fuzzer, so AFL need an unstable program, need a program that every time that you fill it with an input, it get the same result. So if you are obtaining a bad stability score, you have some problem with your randomness in your application. So now we need to look into the code and guess what's happening with the stability score. Okay, I continue answering some questions, so please give me a second. Okay, as I have said before, we need an stability score over 90%. So if you are getting an stability below 90%, please look at it. You need to solve it first of all. So the thing is, the source code is bigger than before. It's bigger than the challenge number 1. So, and we don't have enough time for looking into the code or for looking all the code. So you need to focus on finding something that can how to explain. You need to find something that is really related to random. So that's my next hint. That's the hint number 4. Life can be random. So here the important word is random. There is something random in the code. Oh, do you have find something interesting? Yes, you have found something interesting. Okay, so now I'm going to do again a brief summary of challenge 2. First of all, if you haven't already downloaded it, please go to the GitHub repository and download fast2.zip. Inside, you are going to find two files, two source code files, and also you are going to find an example file. If you open the example file, you're going to find something like this. But of course, you need the next password for uncompressing it. So the password is fast9283fast. That's the password that you need in order to uncompress the file. And then my important thing is, or what was happening is, the stability went under 90. In that case, the stability was about 24%. So when we have an stability under 90%, sorry, we need to look at problematics function. And that's my hint number 5. Okay, that's what you need. If you know a little bit about how randomness function works in C and C++, you should know that sRandom function set up a seed for random function. The thing is, you need to set a seed at the beginning of the program, and then every time that you call the random function, it gets a random number. So the thing is, if you set the same random seed, you are going to obtain always the same sequence of number. Yes, Raf. Yes, Raf say that before after the change, you are going to obtain a 100% stability score. Yes, that's it. That's the thing. If we set 1 as the seed of the sRandom function, you are going to obtain a 100% stability, because of course you are getting always the same random numbers in our program. So that's the objective, that's the goal. Okay, there are some people complaints about the GoToWebinar signal, but okay, I'm back. So Okay, so now if we comment this line, we are going to be able to obtain a 100% stability score. So what next? That's the next hint. That's the hint number 6. And the question is, can you find the difference? We have binary formats as in the challenge number 1, and in that case, we have a text-based file format. So what's the difference between a binary format and a text-based file format? Okay, there's Johan asked me, what will be your tips to build a good dictionary? So you always need to include all the constants. In general, you need to include in your dictionary a static arrays. I mean, arrays that whose size are greater than 2, and constant strings. So we are going to do another summary. Maybe someone got lost. So first of all, you need to go to the workshop, to the Hackfest Advanced Fuzzing Workshop repository, and download the fast2 file. You need to use the password fast9283fast, and you are going to find 2 files inside. Well, you are going to find 3 files: hackfest2.c and the header file also, and the example file inside. And if you open the example file, you're going to find something like this. You're going to see something like this. Then the next step is to look at the AFL GUI, at the AFL interface. And if you have an stability score below 90%, in that case is 24%, you need to fix the randomness of your program. In that case, my suggestion is to comment this line as random. That is the seed random function. I mean, is the function that set the seed for all the future srand calls. So you need to set it to with a constant value. In that case, I choose 1. And after that, my question is, are you able to find the difference between a binary format and a text-based file format? Because you need to remember that in that case, we have something like an XML format. So it's a text-based format. So that's my suggestion. Maybe binary mutations are not the best for text-based file formats. So take a look at the next address and look for custom mutators entry. That's what you need now. Custom mutators. That's the URL. That's the web page that you need to go. And then you need to look for the custom mutators section. Because of course, in that case, the bit mutators of AFL are not the best for a text-based file format. So my recommendation is to use a custom mutator in order to get the class. Okay, well, there are some people doing the custom mutator step. Perfect. So now I'm going to show you the hint number 8. And hint number 8 says, have you ever heard of Radamsa? Do you know about Radamsa? Radamsa is a fuzzer that recently AFL has included into their custom mutator. So please go to the next URL and you will be able to find more about Radamsa. Okay, that's the URL that you need. That's the URL of Radamsa. Okay, I'm going to show you again what you need to do in order to obtain a 100% stability, or in order to solve the instability problems. You need to set a constant seed for S random function. And my first advice is to use Radamsa, but that's my second advice. That's the hint number 9. The thing is, are you getting problems with slowing the fuzzing process? Sorry, is your fuzzing or is AFL too slow? So my advice is try disabling address sanitizer and undefined behavior sanitizer in case you were using it. If you are using address sanitizer or undefined behavior sanitizer, you can disable in that case, because we are looking for a bug that you can find without sanitizers. So, of course, sanitizers slow down the fuzzing process. They allow us to find more vulnerabilities, but they also slow down the fuzzing process. So okay, so that's the hint number 9. There are some people asking me question, but the thing is, at this moment, 5 minutes left. And pay attention, because that's the most important hint. The hint number 10, and it says MOPT is an excellent mutator. That's my last advice for challenge number 2. That's the hint number 10. That's my advice. Use MOPT because it's an excellent mutator. Okay, for those who didn't have who don't have experience with MOPT, I'm going to provide you with a link. Give me 1 second, please. Okay. Okay, that's the link that you need. MOPT. Okay, 4 minutes left.
Hey, Antonio. There's 4 minutes left, but if you want to continue, there's no one after you for another hour. So, like you prefer, no issue.
Okay. So, okay, I am going to continue for 10 or 15 minutes more because it was I can I'm able to continue for 15 or 20 minutes more, but an hour is
No, just saying there's an hour possible. No issue, whatever you can.
Okay. Thank you for letting me know. So yes, we are going to extend a little bit more the time, 10 minutes. Okay, so we are going to do a review or a summary of all the process again. There are some people that are at this moment are close to the solution. So first of all, you need to go to the GitHub repository and download the fast2 file. You need to use the fast9283 fast password, and inside you are going to find 3 different files. You are going to find 2 source code files, and the third one is the example file. The example, you can open the example file and you are going to find something like a XML file. So after that, if you start to fast using AFL, you are going to observe that stability is really low. In my case, stability was something like 24%. So for fasting in a proper way, we need an stability over 90%. Over 90%. So what was my suggestion? My suggestion was that you need to look for randomness. In that case, there are a function that you can see here that is setting the random seed. That's the function that set the random seed. So what I changed was the sRandom line. I comment it out, and I set an static value, a constant. In that case, you can see that I have changed sRandom by a sRandom1. And after that, I explained that there are great difference between binary formats and text-based formats. So for binary formats, obviously AFL regular mutations are perfect because AFL employ bit mutation, byte mutation, arithmetic mutation, but these mutations are not so good for the case of text-based file formats. So my next advice was to employ a custom mutator. What is a custom mutator? A custom mutator is a mutator that does not, in that case, that does not binary change in the input file. So of course, AFL++ allow us to build our own custom mutator, but that is a little bit hard for a 2 hours workshop. So my advice is to try with other 2 mutator. The first one is Radamsa. You can go here to find how to build Radamsa and use it. Of course, if you are experiencing some slowdown problems, if you are getting a slow speed, you can try disabling address sanitizer and define behavior sanitizer. And my second advice is use MOPT. MOPT is an excellent mutator, and it goes really well with text-based format. So, okay, 5 minutes left. I'm going to ask some question, and after that, I'm going to give my own solution. Okay. We're going to wait for 4 minutes more. Okay, 3 minutes left. I'm asking some question, and after that, I'm going to explain my solution. Two minutes left. So the thing is to use MOPT mutator, and that's my last advice. That's my last hint. You can enable OPT mutator setting Okay, and now obviously I'm going to show you my solution. So if you haven't found the crash, don't desperate, because of course in that case it is a bit trickier. So as you can see here, I'm not going to reproduce the fuzzing session because it takes about 10 minutes. But in that case, you can see that I have found it in 11 minutes. So what I did? Well, as you can see here, I have enabled MOPT mutator. MOPT mutator is a optimized mutator that was included in AFL++ some time ago, and I really recommend to you use it if you are going to be serious with fuzzing. So in general, I recommend to you to use different mutators, not only the standard AFL mutators, if you are going to fuzz other thing than binary formats. So for binary formats, AFL standard mutators are totally perfect. But if you are going to fuzz test-based file formats, for example, I recommend to you to use MOPT, Radamsa, or if you have enough time, you can create your own custom mutator. So that's the bug. That's the vulnerability. It's a stack buffer overflow. Yes, there is a stack buffer overflow in the code. And if you go to the setall function, you're going to be able to see it. And what is the vulnerability? Because in that case, I want to explain a little bit more about these vulnerabilities. Well, the vulnerability is not complex at all. If you look into the input, into the original example, that's the original example, and then you look into this code, you are going to appreciate clearly what is the where is the vulnerability in that case. The vulnerability is here, obviously. You can see here. In that case, the vulnerability is triggered when the following conditions are okay. So the vulnerability is triggered, or it is in the size function. That's the size function. Okay. So, and it's triggered when you set a third argument whose size, or with a size greater than 128. And what's the reason for that? Why we need to set a 128 size? So I'm going to show you what is the reason. Give me 1 second. I'm going to share with you again the virtual machine. Okay. Can you see my virtual machine now? Okay, thank you. Perfect. So now I'm going to move to Hackfest 2. Yes, that's it. And I am looking for something like that. That's it. So that's the buffer that we have overflow with our exploit. I'm going to show you that the exploit works. That is not a joke. I have here the Hackfest number 2. So you only need to run the Hackfest 2 application with this file, and you can see that address sanitizer is showing us that there is a stack buffer overflow. And of course, we can debug it. I'm going to debug it. Give me 1 second. I'm going to debug it. Okay, and I'm going to provide it with the file that triggered the bug. That is, where is it? Okay, that is the crash. And now we are going to see the process inside the debugger inside GDB. Okay, so that's it. GDB has intercepted the bad operation, and that's it, the sentence that triggered the bug. As you can see here, that's the sentence. The sentence is setall, and is called from function number 4. Function number 4 is the function that handle the size the size lines or the size commands. As you can see in the slide, well, not now, but as you are going to see now before in the slides, there are different commands. One of them are size, the size command, and the size function, or the function for that handle size, call here to this line, and this line trigger the bug. This was a bit tricky, of course. It was it is a bit difficult because I have the buffer that we are overflowing is not here. It's not inside the process. It's not inside the setAll function. It's inside process, and what I did is to create an external pointer to the stack base buffer, and I overflow it before. So it's a bit tricky. So don't desperate if you haven't found it, because it's a little bit tricky. And of course, we had only 2 hours, so it's difficult to find it in 2 hours, and well, in 1 hour in this case. And of course, from the distance is even more difficult because all the things get more complicated. So, but I'm going to return to the slides to show you the end of the presentation of the workshop. So that's the vulnerability. You can try it. You can get the example file that I provide to you and set up a big float number. It's important to be that it will be it is a float number. So you can set up a float number greater, or whose size is greater than 128. That is the size of the stack base buffer, and you are going to see that the program crashes. And why I choose or why I choose this vulnerability. So well, the reason is, some time ago I found a vulnerability in Notepad++. I'm sure that all of you know about Notepad++. So I was looking into the code of Notepad++, and I found this vulnerability. This is the report I sent to HackerOne some time ago, and I was rewarded with $2,800, and it was considered as high severity. And that's the vulnerability. If you look into the text, you are going to see that the encoding field in this XML file is bigger than usual. So yes, the vulnerability was quite simple, but at the end, you need to use the right tools in order to be able to find this type of vulnerabilities. Because of course, if you use AFL, for example, if you use AFL per se, if you use AFL in the default mode with the binary mutators, the normal mutators, you are not going to be able to find this vulnerability in this type of formats. So my advice is to think about the format file, or the format of the file that you are facing, and choose a proper mutator for each file type. And the thing is, if you are not sure, try with 2 or 3 different. So if you, for example, don't have time for thinking about it, go with 2 or 3 at the same time. You can run different instances of AFL at the same time. So for example, you can run one instance with simple AFL, another instance with MOPT mutator, and another instance with RADAMSA, for example. And of course, you can create your own custom mutator, but we don't have enough time for explaining how to create a custom mutator, and it's a bit difficult. It's a bit tricky. So now we have finished with challenge number two, and challenge number 3 is different because, and why is different? Because I'm not going to announce the winners now. So we have 2 winners for challenge number 1. I'm going to send to these winners now the code for GitHub shop. The code is, sorry. But we don't have any winner for challenge number 2. So what I am going to do is I'm going to give you 1 week for challenge number 3. Of course, I'm going to publish challenge number 3 next Monday. So you are going to have 1 week for solving challenge number 3, and there will be 4 winners. So there will be 4 prizes for. Okay, Tom Richards, yes. Can you send me the grass? Tom, please send me the grass. I'm going to check it, and if it's okay, you will be the winner of challenge 2 also. You have been the first in challenge 1, and you're going to probably be the the winner of challenge number 2 too. So coming back to the challenge 3 explanation, I'm going to publish challenge number 3 in my GitHub repository, and I will announce the challenge number 3 winners next week in my Twitter account. Of course, if you are one of these winners, I'm going to notify you. I'm going to send you a message. And yes, Juan does say that he's at 15 minutes. Yes, of course, it depends also a little bit. It depends on lag. I mean, it is this type of mutators are not have a little component of randomness. So at the end, it's pure lag, but you know, Tom has winning. Okay, I'm gonna 1 minute. I'm going to check again the file that Tom provided to me. One second, please. Cool. Yes, that's it, Tom. You have found, if you can see if you open the file that you sent to me, Tom, you are going to be able that you have found the same bug that I'm explaining here. So in your file is the same, but of course in your case is the string is even bigger, but it's the same vulnerability. So yes, Tom Richards is the winner of the second challenge. So challenge 2. So after this workshop, I'll send to you 2 different codes. You can use them for the Shopify GitHub shop. So, and that's it. Next Monday, I will upload the challenge number 3 to my GitHub repository. And now my conclusion. My conclusion is don't waste fuzzing iterations. Use your brain first, because at the end, you are wasting a lot of energy. You are doing a lot of power consumption. So don't waste fuzzing iteration. Use your brain first. And that's it. That's the end.
Hey, thanks a lot, Antonio.
Thank you to everybody. Thank you to everyone. And of course, I know that it's a bit difficult to follow this type of hard workshop from the distance. I know it, but you know, due to the pandemic situation that we are all living now, it's impossible to be there in Canada. So, but anyway, I have been. It has been a pleasure for me to be here from the distance, of course, and thank you to all for participate in this workshop. And thank you, of course, to Hackfest organization for taking me into account for this workshop. Thank you.
Thanks again. If you want to switch on the Q&A Discord chat, if anyone have any other question, you can follow up there. I'll just text you right there.
Yes, of course.
And thanks again. This will be, I think, online, and we'll follow up with your next challenge that you said you're going to release. If you can update us with this, that'll be awesome. We can publicize it also.
Yes, I will do. I will do for sure. Thank you. Thank you.
Have a good one. Thanks, everyone.